Hello everyone, today we're going to be going with the square root rules, and these are going to be made simple, and hopefully I can get this done in 10 minutes. Alright, so starting off with the product rule. The product rule is where we split the square into square roots to multiply the outside. So essentially, we're simplifying and breaking down the roots. The way I like to remember the product rule is basically just saying product means multiplication. And this will come in handy when you're trying to remember another rule that we will go over soon. And it will really, it's like a mnemonic, but it's not. It's just a quick thing to remember. Product equals multiplication. Anyways, so for the rule, I have square root of a times b equals the square root of a times square root of b. As we see, we have these two terms under the same square root, and then essentially we break them down and put them under their own square roots. So let's do a quick example together. So I'm starting off with the square root of 12. I'm going to break this down. So I know to get to 12, I'm going to use a multiplication problem. A multiplication problem I could use is the square root of 4 times 3. I know 4 times 3 equals 12. So I'm going to separate the 4 and 3. To do this, I would do the square root of 4 times the square root of 3. So they are now under that same square root. Then I want to break the 4 into 2, because essentially when you have a problem like this, you want to break it down to the simplest terms. For 3, I cannot break that down into a simpler term, or else I would get a decimal, which is 1.5, and we do not want that. We want to stick to whole and divisible numbers. So I would have 2 outside of the square root of 3. That is how we essentially broke that up and simplified the square root of 12. Alright, moving on to our next rule, the quotient rule. And I like to remember the quotient as division. So going back to what I said earlier, the product rule is like a multiplication. The quotient rule is division. They are complete opposites of each other, but they are very unique to remember. They're opposites. So product, multiplication, quotient, division. They are complete opposites. So the definition I have is dividing the square root into simpler terms. Now, this is better showed than explained, and I am going to go over the rule. So I have the square root of a divided by b. To solve this, I would simply put their own terms under their own square roots. So I have the square root of a divided by the square root of b. So let's go over an example. I have the square root of 14 divided by 10. I'm going to break these two terms up and have them under their own square roots. So I'd have the square root of 14 divided by the square root of 10. I know that this is not the simple fraction, and I'm going to break this fraction down. So I would divide this by 2, and I would have 7 divided by 5. So that is how I got that product, and how essentially, even though you're still dividing, oh, and by the way, I'm not dividing like 14 by 10. You see how I put them under their own squares, and that's why I think that's essential before I forget that. I'm basically solving the square by itself. So like the division is just like there. So really focus about like working on those squares. I decided to divide by 2. They're both divisible by 2. 2 is very simple. I know for some equations you do like 3 or 4, but for this equation I decided to use 2. And the 14 divided by 2, that's 7, and 10 divided by 2, that's 5. And I really worked on those independently instead of doing like 7 divided by 10, if that makes sense. So if I did do like a 7 divided by 10, I would get 0.7. That is not what we're doing here, and you're solving the square root and still putting it as a fraction. Alright, moving on to our next rule. The square root of a square. So essentially what we're doing here is we're turning the square root into an absolute value. And if you watched my other video of the basics of a square root and explaining square roots, you would know that a power cancels out a square root. They cancel out each other. So what we're doing here is we're just going to turn a negative value into an absolute value. So let's do an example. I have square root of negative 15 to the power of 2. Simply, this is probably the easiest rule because you're not doing much math or thinking. You're just turning into absolute value, which means we're turning the negative into a positive. So all I would do here is I would remove the power and I would remove the square root and I would just get 15 because once again, a power and a square root cancel out each other. So just a reminder, it has to become an absolute value if you have a negative square root. Square roots are just not negative. They cannot be negative. We cannot make them negative. We have to turn them into an absolute value. Alright, and I do want to go over another rule that I feel like isn't mentioned too much, and I feel like this is essential for students to learn, and it can really help you avoid some common mistakes. So essentially, you cannot split an addition or subtraction problem. We have worked with multiplication, we've worked with division, and we work with negatives. But simply addition or subtraction just wouldn't work here, and this is why we call it an illegal rule. So I have square root of a plus b. That I cannot do a square root of a plus the square root of b. I cannot split those two up, and even if it was subtraction, I still couldn't do that. And I'm going to go over an example and show you why it wouldn't work. Alright, so I have a square root of 9 plus 16. To simplify this, I'd have the 9 under its own square root plus the square root of 16 because essentially I am just dividing them. But in this case, we're going to add them. So let's look at them when we add them together. They equal square root of 25. That is a perfect square because I know 5 times 5 equals 25. This is a perfect square root. But see, it just wouldn't work when we apply the other logic we had to our other problems. So let me show you. So some logic here would be the square root of 9 plus the square root of 16. I'm going to break down these square roots. So working with square root of 9, I know I'm going to get 3. Working with the square root of 16, I'm going to get 4. So now I'm going to add these together because I've solved the square root, and now I'm going to add the simple values up. I would get 7. It just doesn't work. Even if I did it for subtraction, 9 minus 16, I wouldn't even get the 25. I would get another square root, and I would still have to go through the same process of trying to solve it, like similar to the other ways we solved the rest of the rules. And this is just why addition and subtraction wouldn't work. It is just simply an illegal rule. So, thank you for watching. This is Ari, the math tutor, signing out. And today's lesson, essentially, all we did was figure out the rules of square roots, an illegal rule, the quotient rule, the product rule, and the square root of a square. This is Ari, the math tutor, signing out. And I hope to see you guys next time.